Next, let's take a look at question number 6. Question number 6 asks us to find a maximum possible error in using a given expression. So at the first glance of this given expression, it looks very similar to the first few terms in the Taylor expansion. And then you have x minus 1 raised to the power 1, raised to the power 2, raised to the power 3. So it makes you think that this is probably P3, right? And then if we are using the P3 of x to approximate the function, then our error, maximum error, is going to be the remainder term, which is going to be R3 of x. So as long as we can make sure that the absolute value of R3x is less than or equal to a constant, then that constant is going to be your maximum error. And that is how we approach this question. But before we analyze this remainder term, we do need to make sure that this given expression, it is indeed the P3 of x. So let's try to find the P3 of x and compare that with this to see if they are exactly the same. Okay, so we know that P3 of x is going to be sigma n from 0 to 3, and then you have fn of x0, but in this case your x0 is 1 because we're expanding it at x0 equal to 1. So it's going to be 1, right? And then x minus 1 raised to the power n divided by n factorial. Okay, so we need to find the nth derivative. In this case, it's the derivative all the way up to the third derivative. So let's take that. So we have f of x starting with ln 2x plus 5. And then we take the derivative, f prime of x is going to be 1 over 2x plus 5 times 2 by the chain rule. But we want to write that as 2x plus 5 raised to the power minus 1 times 2 for convenience, because it's easier for us to differentiate later on. And then we have the second derivative, that is just differentiate this one. So negative 1, 2x plus 5, negative 2 times 2 raised to the power 2. And then continue. The third derivative, negative 1, negative 2, 2x plus 5, negative 3, and then multiply with another 2, that's 2 raised to the power 3. And then how about let's just take the fourth derivative, because we will use that in our remainder term later on. So negative 1, negative 2, negative 3, and then 2x plus 5, negative 4, 2 raised to the power 4. Okay, so everything is ready. So let's plug in 1. If we plug in 1 in here, we're going to get ln7, which matches this term, right? That is f1. And then if we plug in 1 in the first derivative, we're going to have 7, right? 2 over 7, which matches the coefficient here. And then if we plug in, what do we have? 1 in here. Actually, just point at here, probably easier. We plug in 1 in here, we're going to have negative 1 multiplied with this, which is the 7 square in the denominator, and then 2 square on the top, which matches exactly this coefficient. Keep in mind that we still have this, also have this negative 1. And then plug in 3, we're going to have plug in 1 in here. We're going to match this term, this coefficient. So we can see that after our computation, this is indeed the P3 of x. Okay, so this is our P3 of x. So now it's safe for us to calculate the remainder term and then try to find a bound, upper bound for that. So by definition, our remainder term, it's R3 of x equal to F4, and then evaluate it at Z3, and then x minus 1 raised to the power 4 divided by 4 factorial, where Z3 is between x and x0, which is in this case x and 1. Okay, x and 1. And then let's actually draw a number line to make sure that we are not so confused. So it looks like that in the number line. That is like this. So you have your 0.1, and then this is 0, this is 1, right? The question says that x ranges from negative 0.1 to 0. So x is sitting at here. This is your x. And then your z and z3 is between x and 1. So it's going to be somewhere in here. That is your z3. In order for us to approximate this R3 of x, we will need to take the absolute value. So let's just copy and paste that. Take the absolute value, right? And that's going to be absolute value of this, which is going to be less than or equal to the product of the absolute value of each individual. So that is this. With absolute value here, absolute value here, right? Like that. So if we want to find an upper bound for this remainder term, we just need to find upper bound for this guy, this, and then this guy, right? Separately, and then we multiply them, which is going to be the upper bound for R3 of x. Okay, so let's do that. So let's find this one first. F derivative for z3. We know what that is like. So that is this one with z3 plugged in. Right, so we plug in z3 here. Replace that with z3. And then there's going to be replaced with z3. Right? We can simplify that a little bit. That is negative 3 factorial times 2 raised to the power 4, which is 16, divided by 2z3 plus 5 raised to the power 4. Okay, so that is this one. And then we know where z3 is sitting at. But notice that this x is movable. So you can push x all the way to this negative 0.1, which is going to expand the space for some more rooms for z3. So technically, z3 could be in between negative 0.1 and 0. So that's the range of z3, right? So let's try to find out what this one is ranging. So we have z3, negative 0.1, right, in between that and 1. It doesn't actually have the equal sign because it's strictly in between by our definition, right? And then we're going to multiply by 2. So 2z3 is going to be 2 negative 0.2. And then we will plus 5. So 2z3 plus 5 between 7 and this 4.8, right? And then we take the fourth power, 2z3 plus 5 raised to power 4. That is 7, and then 4.8 raised to power 4. And then take the reciprocal, okay? Like I said, it's messy. We know that, right? It's very tedious. So take the derivative, take the reciprocal. It's going to flip the inequality sign. So that is 1 over 4.8 raised to power 4. So we know that this guy is going to be in between this and 4.8 raised to power 4. Raised to power 4, not 4.84. So that's the upper bound for this one. Okay? So we know that this one, if we take the derivative, so that tells us this. Take the derivative of, take the absolute value, not the derivative, right? So it's going to be less than or equal to 3 factorial times 16 divided by 4.8 raised to power 4. Okay? So this guy is already done. Let's move on to do the next one, which is x minus 1 raised to power 4. Okay? So we know that x ranges from negative 0.1 to 0. So let's start from there. So x is negative 0.1, 0. And then we'll minus 1. Minus 1, we have negative 1, negative 1.1. And take absolute value. And it's going to be 1.1. And this is going to be 1. Okay? And then raised to the power 4. Take absolute value. Raised to the power 4. It's going to be like that. Okay? So now we see that the upper bound for this guy is 1.1 raised to the power 4. Let me highlight that. This is the upper bound for the previous one. And then this is the upper bound for this one. Okay? And then we're going to use that. This one is this one. So use both. Use this one and this one. Right. So now use them both. So this is going to be less than 3 factorial times 16 divided by 4.8 raised to power 4. Multiply with this 1.1 factorial. 1.1. Let's write it on the top. That is 1.1 raised to power 4. And then we have 4 factorial in the bottom. Messy. Actually, I wanted to write that out in the next line because it looks quite messy right now. Okay, write that like that. Okay, and then we will do some calculation here. The 16 will be cancelled with this 4, and then we will be left with the 4 on the top and then 3 factorial in the bottom. Okay, so that is going to be 3, and also this 3 factorial cancel with this 3 factorial. Okay, 3 factorial cancel with this 3 factorial. So we are left with 4 multiplied with 1.1 raised to, again, quite messy, 4 multiplied with this 1.1 raised to the power 4 divided by 4.8 raised to the power 4. Okay, and then it's time to plug into a calculator, and then the after you plug in, you will see that the, what is that? The answer is going to be 0.011. Okay, so it's a messy question, right? Most of the steps are just from calculation, but I don't want to talk too much about that. I just want to see the big picture, focus on the main component of this question, right? Starting with recognizing that this expression is indeed P3 of x through our calculation, so that we know that we can focus on analyzing the remainder term, and then we should point out where x is ranging, where the z3 is ranging, and then start to work on the remainder terms using the triangular inequality. So we know that it boils down to calculating the upper bound for each of these factors, which we did here, right, through some complicated, strenuous calculation, and then they're bounded by one is by that, the other one is by that, and then we just multiply them, and then the calculator tells us that this is the maximum error. So that's it for this question. If you have any question, just let me know.